Hi, this question is taken from JEE Advanced 2019 from its first paper. So the question is a numerical type question. So let us go ahead and solve this. But before going through the solution, I would recommend all of you to pause this video at this moment and give this question a try. So yeah, let's go ahead and try this out, solve this question. Let omega not equals to 1 be the cube root of unity. Omega not is equals to 1. So when it is given that omega not equal to 1 and it is the cube root of unity, two things that should come to your mind is 1 plus omega square is equal to 0 and omega cube is equal to 1. So put these things in the back of your mind. Then the minimum of the set. So we have to find the minimum value of magnitude of a plus b omega plus c omega square whole square, and a, b, c are distinct non-zero integers, not equal to 0 and distinct integers. So let us go ahead and solve this. So let us solve this expression. So this will be a plus, so we know that z into z bar is equals to mod z square. So where z is a complex number and z bar is its conjugate. So now mod z bar square can be written as z into z bar. So a plus b omega plus c omega square whole square is equals to a plus b omega plus c omega square multiplied by a plus b omega plus c omega square whole bar. And from this, so here it is omega cube is equals to 1. So omega into omega square is equals to 1. Sorry. So omega is cube root of unity. So we know that omega square is equal to omega bar, conjugate of omega. Also omega is equal to omega square whole bar. Alright. Now let us go ahead and multiply this. This will be a plus b omega plus c omega square times. So this will be a bar plus b omega bar plus c omega square bar. A bar is a because it is an integer, plus b omega bar plus c omega square bar. A plus b omega plus c omega square into a plus b omega bar can be written as omega square from this. And similarly omega square bar can be written as c omega. So now just multiply this out. A square plus ab omega square plus ac omega plus ab omega plus b square omega cube plus bc omega square plus ac omega square plus bc omega power 4 plus c square omega cube. So a square omega cube is 1, so this term will be b square. Similarly this term will be c square. A square plus b square plus c square. Now if you consider this term ab omega square and ab omega plus ab into omega square plus omega. Similarly these two terms ac into omega square plus omega plus bc into omega square plus omega. From this omega square plus omega is minus 1. So this will be a square plus b square plus c square minus ab minus bc minus ca. So we have to find the minimum value of this when a, b, c are distinct non-zero integers. So multiply this with half and divide the whole expression by half. So that will give you 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca. So half into this can be written as a minus b whole square. That is a square plus b square minus 2ab plus b minus c whole square plus c minus a whole square. So this is the expression. So now a, b, c are distinct. So the minimum difference that we can have between any two of them is 1. Alright. But when, let us say, without loss of generality, let us say a greater than b greater than c. So the minimum difference between these two can be 1, and the minimum difference between these two can be 1, and minimum difference between these two can be 2. So all of them cannot be 1 simultaneously. So a minus b cannot be a minus b, b minus c, c minus a. All of them cannot be 1 at the same time, because even if you take consecutive integers, let's say 4, 3, 2. So this difference is 1, this difference is 1, and this difference will be 2. So at least one of them should be 2. That is the minimal case. So the minimum value will be 1 square plus 1 square plus 2 square. So that is 6 by 2. So that is 3. This is the minimum value of the given expression. So just for the sake of solving, I did all of these algebraic manipulations. But this is a very famous expression. Whenever you see this expression, you should be able to write this directly and then this without even thinking about it. The moment you saw that expression, you should be able to write this. This is a very, very famous expression. And then this just takes maybe a minute to solve this question. This question can be solved literally in under 1 minute.